session, we start a classroom workbook based on inverse Laplace transforms. Let us start the session with question number 12. The inverse Laplace transform of f of s is. The inverse Laplace transform of f of s is. Options are given. What is f of s? F of s is s plus 10 divided by s plus 2 into s plus 20. S plus 10 divided by s plus 2 into s plus 20. Here the denominator contains s plus 2 and s plus 20 terms. So definitely the answer will contains e power minus 2t and e power minus 20t terms. So let us go through options. So in every option we have e power minus 2t and e power minus 20t. In every option we have e power minus 2t and e power minus 20t. So no use with this. Now let us try to find the values of a and b. Here let us try to get this by using partial fraction expansion. So s plus 10 by s plus 2 into s plus 20. Here the power of s is 1, the power of s in the denominator expression is 2. It is 1, it is 2. 1 less than or equal to 2. Therefore this can be written like this: a by s plus 2 plus b by s plus 20. Cross multiply this equation becomes s plus 10 equal to a into s plus 20 plus b into s plus 2. Now one way is you can get the values of a and b. Another way is this, or you can get easily the value of a. So to get the a value, take s equal to minus 2. So this becomes minus 2 plus 10, 8 equal to, so this is minus 2 plus 20. So this is 18a. So a value is 4 divided by 9. So we have only one option with a value minus that is 4 by 9. So actually this 4 by 9 is coefficient of e power minus 2t, because inverse Laplace of 1 by s plus 2 is e power minus 2t. Therefore the answer is B. Because in option B only the value of a is 4 by 9. Only one option contains a value 4 by 9. So it is option B. Or you can do like this. Here a value 4 by 9. So when you take s value minus 20, this becomes minus 20 plus 10, minus 10 equal to, this is minus 20 plus 2, minus 18b. So here b equal to 5 by 9. So a value 4 by 9, b value 4 by 9. Therefore this is L inverse of a is 4 by 9. 4 by 9 divided by s plus 2 plus this is 5 by 9 divided by s plus 20. Apply linear property, this becomes 4 by 9 into L inverse of 1 by s plus 2 plus 5 by 9 into L inverse of 1 by s plus 20. So therefore this is 4 by 9 into this is e power minus 40 plus 5 by 9 into this is e power minus 20t. So that's why it is option number B. Now let us discuss question number 13. The Laplace transform of small f of t is 1 by s square into s plus 1. Then f of t is. So Laplace transform is given, they were asking f of t. So indirectly we need to find inverse Laplace of this. So we need to find inverse Laplace of 1 by s square into s plus 1. We can do this by partial fraction or by convolution theorem. So let us handle this by convolution theorem. This is L inverse of 1 by s square into 1 by s plus 1. This is L inverse of this 1 by s square is Laplace of 1 and this is Laplace of e power minus t. So therefore this is in the form L inverse of L of f of t dot L of g of t. So by convolution theorem this becomes 1 star e power minus t. So convolution product, this is integral 0 to t, f of capital T, this is 1 only, g of t minus t, so e power minus of small t minus capital T into dt. So here we are doing integration with respect to capital T. So small t is a constant. So e power minus t you can take before integral 0 to t into e power t dt. So therefore this is e power minus t into integral e power t is e power t, limits are from 0 to t. So this becomes e power minus t into e power t minus 1. Therefore this expression is 1 minus e power minus t. So this is 1 minus e power minus t. But is this true? Actually L inverse of 1 by s square. This is a t actually. So therefore in this case this is a t. So this is a t star e minus t. This is f of capital T. So we will get this is capital T times this. So even you can cross check it. When you cross check it, you can understand whether you have done right or not. So it's a wrong calculation. So therefore L in 1 by s square is a Laplace of small t. This is Laplace of small t. So therefore this is small t star e power minus t. So f of t is this small t and g of t is e power minus t. So here we need to write f of capital T. So capital T into this. Therefore this is e power minus t into integral 0 to t times e power t dt. Now this is e power minus t into, so apply integration by parts, this becomes e power t into t minus 1. Limits are from 0 to t. So therefore this is e power minus t into, replace capital T by this, you will get e power t into t minus 1. Replace capital T by 0, e power 0 1, this is 0 minus 1. Therefore this value is e power minus t into e power t. So 1, so this is t minus 1, this is plus 1 into e power minus t. So therefore this is t minus 1 plus e power minus t. This is one way. Another way is you can go through partial fraction expansion. And another way is if you feel that options are complicated, question is complicated, then cross check it by using Laplace transforms. Just you can find the Laplace transform of option A. If you get this, A is right answer. Otherwise you can do this for B or C or for D. So finding Laplace is not a big issue because all options are functions of t or exponentials. So for any problem when the questions are given like this, if you are able to handle them by partial fraction, do it. Otherwise you can do this by convolution. So when you are handling through convolution, be careful about simplifications. So there are some chances to do mistakes. So in that case what you do is you go through options by verifying Laplace transform of each option. If Laplace transform of first option is this, your answer is right. Otherwise you do it for B. If Laplace of second option is this, B is right answer. Like this you can verify easily. Okay. So note these points. Now let us discuss question number 14. The function f of t satisfies the differential equation d square f by dt square plus f equal to 0 and the auxiliary conditions f of 0 is 0, df by dt at t equal to 0 is 4. The Laplace transform of f of t is. So this is application of Laplace and inverse Laplace to solve differential equations. So let me write the differential equation. This is d square f by dt square plus f equal to 0. The boundary conditions are like this. F of 0 equal to 0. Second boundary condition is f dash of 0 equal to 4. So they were asking Laplace of this function. Let us apply Laplace transform for this differential equation. This is f double dash t plus f of t equal to 0. So apply Laplace on both sides. Laplace of f double dash t plus f of t equal to Laplace of 0. Now we can apply linear property because we have plus or minus symbol. So we have Laplace of f dash of f double dash of t plus Laplace of f of t. Laplace of 0 is 0. So here Laplace of f double dash is s square into f of s minus s into small f of 0 minus f dash of 0 plus Laplace of f of t. This is f of s equal to 0. Now group f of s terms. This is s square plus 1 into f of s minus f of 0 is 0, f dash of 0 is 4 equal to 0. Therefore, f of s equal to 4 divided by s square plus 1. So, this f of s is Laplace transform of small f of t. So, the option number C is right answer. Discuss question number 15. Given that f of t equal to L inverse of 3s plus 1 divided by s cube plus 4s square plus k minus 3 into s. If limit t tends to infinity, f of t equal to 1, then what is k value? So here f of t is L inverse of this. So basically this is nothing but Laplace of this function. So what is capital F of s? 3s plus 1 divided by s cube plus 4s square plus k minus 3 into s. This is what final value. So here final value is given as 1. But here instead of f of t, capital F of s is given. Therefore, this final value in terms of signal variable is limit s tends to 0, s into f of s equal to 1. So this implies limit s tends to 0, s into f of s is 3s plus 1 divided by s cube plus 4s square plus k minus 3 into s equal to 1. So in the denominator you can take s common, that can be cancelled with numerator s. Therefore this is limit s tends to 0. So numerator is 3s plus 1 divided by, here you can take s common, that can be cancelled with this. Therefore this becomes s square plus 4s plus k minus 3. This is equal to 1. Now replace s by 0, we get 1 by k minus 3 equal to 1. So k minus 3 equal to 1. Therefore the value of k is 4. So option number D is right. Note this point. Given two continuous time signals, x of t equal to e power minus t and y of t equal to e power minus 2t, which exists for t greater than 0, then the convolution z of t equal to x of t star y of t is. So they were asking convolution product of two functions in the variable t. What is my x of t? This is question number 16. X of t equal to e power minus t and y of t equal to e power minus 2t. So we need to find convolution product of these two. So this is x of t star y of t equal to integral 0 to t into x of capital T into y of small t minus capital T dt. So therefore this is integral 0 to t, x of capital T is e power minus t. In replace t by t minus t in y. So this is e power minus 2 into t minus capital T dt. So here small t is a constant. So we can write e power minus 2t before integral into integral 0 to t minus t into plus 2t. So this is e power t dt. So therefore this is e power minus 2t into this is e power t, limits are from 0 to t. So this is e power minus 2t into e power t minus 1. So therefore this is e power minus t minus e power minus 2t. E power minus t minus e power minus 2t. So it is option number A. Now we discuss question number 17. Consider the initial value problem. d square y by dt square plus 4 dy by dt plus 6y equal to f of t. The boundary conditions are y of 0 equal to 2 and y dash of 0 equal to 1. So here we have two functions. On the LHS y function in the variable t, RHS f in the variable t. Boundary conditions are given for y. So Laplace transform of small y is capital Y of s. Laplace transform of this small f of t is capital F of s. So they asked to find Laplace transform of y of s. So we need to find this y of s in terms of capital F of s. So it is a differential equation. Apply Laplace on both sides. This is Laplace of, this is second derivative L of y double dash t plus 4 into y dash of t plus 6 into y of t equal to L of f of t. We have applied Laplace transform on both sides. And here we have plus symbols, apply linear property. So this is the Laplace of y double dash t plus 4 times Laplace of y dash of t plus 6 times Laplace of y of t equal to Laplace of f of t is f of s. Now this implies this is Laplace of second derivative, Laplace of first derivative. We have a formula to find the Laplace of nth derivative. So here the formula is s square into capital Y of s minus s into y of 0 minus y dash 0 plus 4 times, to get the Laplace of y dash of t, n value is 1. So this is s into y of 0, sorry, this is y of s minus y of 0 plus 6 times Laplace of small y of t is y of s equal to capital F of s. Now substitute these two boundary conditions. Y of 0 is 2 and y dash of 0 is 1. So before that you can group y of s terms. So s square plus 4s plus 6 into y of s. This y of 0 is 2. So therefore this is minus 2s. Y dash of 0 is 1. Minus 1. 4 into y 0. This is minus 8 equal to f of s. So therefore this quantity becomes y of s square plus 4s plus 6 into y of s equal to, so when you take this to the LHS part, this becomes plus sign. So this becomes f of s plus 2s plus 9. Therefore this y of s is f of s plus 2s plus 9 divided by s square plus 4s plus 6. So therefore we got the answer for y of s in terms of capital F of s. So the answer is B. So simply what we have done is we have applied Laplace transform on both sides and we have done necessary calculations. So we got expression for y of s in terms of capital F of s. Now we discuss question number 18. If the Laplace transform of small y of t is given by, y of t is given function, its Laplace is y of s, is given by 5 by 2 into s minus 1 minus 2 by s minus 2 plus 1 by 2 into s minus 3. So y of t is the function, its Laplace is y of s. So therefore capital Y of s is given. Then we need to find y of 0 plus y dash of 0. So it's a blank question. So small y of 0 plus y dash of 0 is required. So let us find the inverse Laplace of this. We get y of t. After that we can proceed to y of 0 and y dash of 0. So therefore this y of t is L inverse of capital Y of s. So L inverse of this is 5 by 2 into s minus 1 minus 2 by s minus 2 plus 1 by 2 into s minus 3. So apply linear property. This becomes 5 by 2 into L inverse of 1 by s minus 1 minus 2 into L inverse of 1 by S minus 2 plus 1 by 2 into L inverse of 1 by S minus 3. So therefore this becomes 5 by 2 into L inverse of 1 by S1 is 1 by S minus 1 is e power t minus 2 into this is e power 2t and this one is 1 by 2 into e power 3t. So you can easily guess what is y of 0. Y of 0 is, so replace t by 0, you get 5 by 2 minus 2 plus 1 by 2. 5 by 2 plus 1 by 2, 6 by 2, 3 minus 2, it is 1. So y of 0 we got it as 1. Let us find the derivative of this. So here y dash of t equal to derivative of this is 5 by 2 into e power t. The derivative of this minus 4 times e power 2t and the derivative of this plus 3 by 2 into e power 3t. So therefore y dash of 0 equal to 5 by 2 minus 4 plus 3 by 2. So this is 0. Y dash of 0 is 0. Y of 0 equal to 1. Therefore this sum is 1. The answer is 1. Now let us discuss question number 19. If f of s is Laplace transform of small f of t, if this is Laplace transform of f of t equal to 2t square into e power minus t, then f of 1 equal to blank. So this is my f of t, 2t square into e power minus t. Then its Laplace is capital F of s. Then they are asking f of 1, capital F of 1, not small f of 1. So let us find the Laplace of this. F of t equal to 2t square into e power minus t. So this we can write it as e power minus t into 2t square. So this I can write it as e power minus t into g of t. Here to get the Laplace of this, you can apply multiplication by t power n rule or shifting property. Shifting is simple for us. So therefore, before finding Laplace of small f of t, I will try to find Laplace of g of t. So here g of t equal to 2t square. Therefore, its Laplace transform is 2 into Laplace of this t square. 2 factorial divided by s cube. T power n rule. N factorial by s power n plus 1. So therefore, this is 4 by s cube. So here Laplace of this small g of t is 4 divided by s cube. But I want Laplace of small f of t. So therefore Laplace of small f of t equal to Laplace of this is e power minus t into g of t. So here a value is 1. Apply shifting result. This is g of s plus 1. So therefore replace s by s plus 1. It becomes 4 by s plus 1. So this Laplace of f of t is capital F of s. So therefore f of 1 is required. 4 divided by 1 plus 1, 2 cube. So 4 by 8. Therefore this is 0.5. So just you can call it as g of t. So find the Laplace of this 2t square. We are getting 4 by s cube. But I want Laplace of f of t. But f of t is e power minus t times g of t. Apply shifting property. This is g of s minus a. A is minus 1. So it becomes g of s plus 1. So that this becomes 4 by s plus 1 whole cube. So that replace s by 1. We get 4 by 8. That is 0.5. Just it is a simple application of shifting property. Now question number 20. The inverse Laplace of s plus 9 divided by s square plus 6s plus 13. We need to find the inverse Laplace of s plus 9 whole divided by s square plus 6s plus 13. Now let us see. This can be written as actually s plus 9 divided by this we can write it as s plus 3 whole square. So s square plus 6x plus 9, here 4 is left. So we can write it as plus 2 square. So therefore s inverse of s plus 3 by s plus 3 whole square plus 2 square. So therefore this is in the form L inverse of s plus 3 by s square plus a square. But here s is replaced by actually s plus 3. S is replaced by s plus 3. Of course this is 9. So this numerator 9 I can write it as plus 3 plus 6. Now apply linear property, group s plus 3. You distribute denominator to s plus 3 and to 6. So therefore this is L inverse of s plus 3 by s plus 3 whole square plus 2 square plus L inverse of 6 by this s plus 3 whole square plus 2 square. So actually it is in the form L inverse of s by s square plus a square. But in place of s plus 3 is there. That means we have applied shifting property indirectly. Therefore, what is L inverse of s by s square plus a square? Cos at, a value 2. So this is cos 2t. But s is replaced by s plus 3. Therefore, you need to multiply with e power minus 3t. Plus, here it must be s by s square plus a square. But s is not there. Constant is there. A value 2. So this can be written as 3 times L inverse of 2 by s plus 3 whole square plus 2 square. Therefore, this becomes e power minus 3t into cos 2t plus 3 times L inverse of a by s square plus a square. So it is the Laplace of cos sin 2t. So sin 2t into, but s is replaced by s plus 3. So multiply with e power minus 3t. So therefore the final inverse Laplace is this. Now this is e power minus 3t into cos 2t plus 3 times e power minus 3t into sin 2t. So option number D. Note this. Now let us move to question number 21. The inverse Laplace of 1 by 2s square plus 3s plus 1. We need to find inverse Laplace of this. So this we can write it as L inverse of, you take 2 common, this becomes 1 by 2 into s square plus 3 by 2 into s plus 1 by 2. So this is 1 by 2 into L inverse of, this expression we can write it as 1 by s plus 1 by 2 into s plus 1. So multiply these two, s into s square plus s plus 1 by 2 s by 2 plus s 3 by 2 s plus 1 by 2 into this. Therefore, this we can write it as L inverse of 1 by s plus 1 by 2 minus 1 by s plus 1. So you simplify this, in the numerator you will get s plus 1 minus s minus 2. 1 minus of 1 by 2 is 1 by 2. Already we have 1 by 2. So therefore the total expression is L inverse of this. Now we have minus symbol, apply linear property, L inverse of 1 by s plus 2 minus L inverse of 1 by s plus 1. So this is e power minus 1 by 2t, this is e power minus t. So therefore this is option number A. Just simple partial fraction expansion. Okay. So take 2 common. This is nothing but s plus 1 by 2 into s plus 1. So we have 1 by 2 into 1 by s plus 1 by 2 into s plus 1. It's a partial fraction expansion. Along with 1 by 2 is 1 by s plus half minus 1 by s plus 1. We have a minus between two functions of s. Apply linear property because it is valid even for inverse Laplace also. So that this is L inverse of 1 by s plus 2 minus L inverse of this. So L inverse of this is e power minus half into t and L inverse of this is e power minus t. So this is option number A. With this we have finished chapter 6, Laplace transforms and inverse Laplace. Thank you so much.